Suppose this is a signal, and if it is considered as on time, and this one in the negative half cycle is off time, if it is considered, then t on plus t off is the total time. So we can write with the integration signal, that is 1 by t integration 0 to t vl dt, that will be equal to 0. And it can be also written in this way, that 1 by t integration 0 to t on vl dt plus t on to total time vl dt is equal to also 0. So t is equal to t on plus t is equal to t on plus t off, and duty ratio is equal to t on, that is the on time by the total time. This is duty ratio, and so it can be also written as 1 by t into vl t on plus vl into t minus t on by t. So vl into t on by t, that means 1 by t, if I consider inside this, then it will be the time period, this unit is second. If I apply this t on by t as d, that into t plus vl into t minus t on by t is 1 minus d into t, and its unit is second, and total of this unit is volt second. So vl dt is actually denoted as volt second, since d has no unit but t has unit second, and vl as the unit volt second. Both volt seconds are balanced volt second. Volt second, this is called volt second balance. And the similar way, if it is a capacitive element is connected, then 1 by t integration 0 to t IC dt. This can similarly be written in this way. This is the volt second balance, and this one is the ampere second balance, since it is connected with current IC. The same way it can be written. This is the ampere second balance equation. This should be equal to 0. Next we'll discuss about Buck converter. Buck converter is also known as step down converter. So this is the construction of buck converter. Here you can see that DC supply is connected, and one switch is also connected in front, and this one is the diode. This is inductor, and this one is capacitor. This is the load. Now if switch is on, then what will happen? The current will pass through this way. So if the current passing through this portion, the diode will be reverse biased. So the diode will be turned off, and the circuit will not be, that is the DC supply will not be supplied through the circuit. So the current now is not passing through this switch. The current is passing through the diode in this way. That current is IDF, and that will be circulated through IL and IC and I naught. Now, in this case, the inductive voltage will be L didt, and this inductive voltage will be equal to VDC, the supply voltage, minus the load voltage or output voltage. The inductive voltage drop will be this. Since the diode is reverse biased, DC supply voltage is not coming, so this will be equal to 0. So 0 minus V naught. And the inductor current IL current is passing through what? The load and the current passing through C. So the current that is passing through this capacitor is equal to C dV naught dt plus load current will be equal to V naught by IR. So let us consider L di dt equal to VDC minus V naught is equation 1, and the inductor current IL equal to C dV naught dt plus V naught by R equal is equation 2. This is when switch is open. So it is the time we consider that is less than the total time and greater than the duty ratio into the total time. So T greater than dt, less than T. So in this case, when the switch is open, the circuit diagram, equivalent circuit diagram will be this way. That is the connection is not coming out. So diode circuit will be open circuited. So this will be the circuit construction for switch is open. Now when the switch is closed, now in this equation 1, if I put, since the DC voltage is not coming, so we can put DC voltage equal to 0 minus V naught equal to minus V naught. And IL also can be written as this way, CD V naught dt plus V naught by R equal to 4. Now I1, and that is equation 1 is equal to equation 2, equation 3, that is turn on time. Now when the switch is off, that is switch is connected, what will happen? When the switch is closed, then the circuit will be like this. Now when the switch is open, the current will flow through the diode and the diode will be forward biased. So in this case, the switch is open, so supply is not coming, so it will be 0 minus V naught. So this is when the switch is open, and current IL will be the similar thing, CD V naught dt plus V naught by R. So equation 1 is turn on. So let us equate equation 1 equal to equation 3. L di dt into dt plus L di dt into 1 minus d into t equal to VDC minus V naught into dt. dt is the duty ratio into the total time minus V naught into 1 minus d into t. That is, the total time period is t. So if I multiply this with d means t on by t, that is equal to d. So dt means dt is equal to t on. So L di dt into t on plus L di dt into t off. So 1 minus d means 1 minus t on by t. So t minus t on by t into t will be t equal to t minus t on. If t minus t on is equal to 1 minus d into t, then t minus t on is equal to t off. Okay, so we are multiplying both the side with t on plus t off. That is, in equation 1, 1 equal to equation 3. So what we are doing? That L di dt into t on plus L di dt into t off is equal to VDC minus V naught, that is the load current, that into t on minus this V minus V naught into t off. Since it is when the switch is open. Switch is open, so that is for the off period, and switch is closed means that is for the on period. So L di dt here equal to minus V naught. So this way we are calculating. So by this way we are getting the output voltage VO equal to, or V naught equal to D into VDC. So the supply voltage you can see is less than the output voltage. So it is called step down converter. So up to this, if anybody has any query, you can ask. So this is for output voltage. Now let us now let us equate equation 2 and now equation 2 and equation 4 are equal. This is not equation 3, this is equation 4. So let us equate equation 2 and 4 equal. Then what we will get? IL into equation 2 was IL equal to C dV naught dt plus V naught by R. Okay, so IL dt plus IL into 1 minus d into t, that means IL into t on plus IL into t off equal to C dV naught dt in plus V naught by R into t on plus C dV naught dt plus V naught by R into t off. Okay, these two will be equal, and from that what we can get? We can get the current value, that is IL into total time equal to V naught by R. So I naught, so IL will be equal to V naught by R, and that is actually the output current. So V output is equal to output current equal to D into VDC, and I naught equal to V naught by R is actually the IL. So IS is the source current divided by the duty ratio is actually the I naught. So what you can see that V naught is less than VDC and I naught is less than IS. This is actually the high current, low voltage, and so this is the DC equivalent of step down transformer. Okay, so here VSIS should be V naught I naught, that is the supply power should be equal to the output power. So IS should be equal to V naught by VS into I naught, and V naught by VS, that is the output voltage by supply voltage, should be equal to the duty ratio. So I naught equal to IS by D. So high current, low voltage, DC equivalent of step down transformer. This is DC equivalent of step down transformer. Okay, so this is all about buck converter, how it is working. And next we will draw the waveform of this inductive current and voltages, how the inductive current and the voltages uh, will work or flow, that we will discuss. Now to draw the load inductive current waveform, what we will do during the on time? During on time, it was the equation L dIL dt equal to VDC minus V naught it was the previous equation. So if you can integrate both side in this way, that integration of di is equal to vdc minus v naught by l dt. So integrate both side, you will get il value. Il is equal to what? vdc minus v naught by l into t plus k1. K1 is the integration constant. Some constant will definitely come. So this is K1. Okay. Okay. So this is now for off, during off period, L dIL dt equal to minus V naught. From the previous equation we are discussing. So integrating both sides, you will get IL. For the off time, IL equal to minus V naught by L t minus dt. This is the off time dt plus IL max. That is maximum inductive current that we are getting. That is our constant. Okay, integration constant. So this will be our mm, current equations, and this is our current equation. So if I can draw this, the current IL has a minimum value and maximum value, and it is continuous curve. It is a continuous curve. You can see it has some jump, that is, it is not touching the zero axis. So it will have the continuous curve. The curve is repetitive. So it may have ripple and DC component. So let us assume IL is the inductive current, that is constant current, but due to some disturbance it has some ripples. Okay. Now the current IL varies from minimum to maximum value, and that value, I minimum to maximum value, is delta IL, and this delta IL is known as ripple current. Okay. So if you can see that this is our then okay, so this is the curve. Mm. Okay, so suppose this is our voltage, switch voltage. Switch voltage will have off time and on time. First of all, switch is closed. So This is VDC. The supply voltage is coming out. And this one is okay. So this way it will repeat. And there will be a little jump on this curve, and this is our inductor voltage. This portion, this point is I minimum current. And during the time when the switch is closed, during the time when the switch is closed, the inductor is getting charged, and we are having this much of voltage, but it has maximum voltage. It is being charged at I max. Okay, so this is the maximum value it can reach, and the maximum value it can reach with the slope V naught by L. VDC minus V naught. VDC minus, this is the slope for on time, during on time, VDC minus V naught by L. And then again it will discharge its charge with the slope minus V naught by L. Okay, and this way it will repeat. Okay, this way it will repeat. So again it will charged and discharged in this way. So this slope is also minus VDC minus V naught by L, and this is again minus V naught by L. Okay. So there is a since it is inductive inductive current, it is not touching the zero axis. It has continuous current flow. So we are getting the output current, that is the inductive current, we can get in this way. IL minimum, this is the IL minimum. Similarly from this above equation, this is the IL minimum, this is IL maximum. And again this is during on time, and this is for off time. Again it is starting from this. So this is on and this is off time. And the output voltage will be like this. Okay, now this is the output voltage will be equal to VDC minus V naught. This is VDC minus V naught. Okay, and this is V naught minus V naught rather, or V naught, whatever it may be, it should be the amplitude. This is inductive voltage VL. Okay, is minus this portion is minus B naught. So what you can see that the voltage is equal to minus